Okay. So the name of the topic is further algebra. It is chapter number 7 of Pure 3 book. So first of all, before beginning the chapter, I will tell you the weightage of this chapter in P3 paper. So the weightage of this chapter is 10 marks, and what topics we are going to cover here. So this chapter divides into 4 exercises according to the Holders publisher. So in the 4 exercise, what we gonna learn? We are going to learn partial fraction. We are going to learn about binomial theorem. It is different as compared to AS level. Binomial theorem. And the third one is integration on partial fraction. Basically, integration we will mostly do in chapter number 8, right? Some of the question we do related to partial fraction, right? Some of the question of integration we do, but mostly we do integration in chapter number 8, right? So the weightage of this chapter is 10 marks. So if you see the past paper question, first of all, they will ask, because the 10 marks question will divide into two parts, 5 marks and 5 marks. In first part, they will ask the question from partial fraction, and on the same, I mean by using first part, you will have to solve B part, right? In B part, they can either ask binomial theorem or they can either ask integration, right? So this is all about, I mean, the weightage and what we're gonna cover in this chapter.
Okay.
Okay, without wasting our time, let us jump into the chapter. Hmm. Okay, the very first topic of this chapter is binomial theorem. Now, you will have a question in your mind, sir, binomial theorem though we have done in ES level as well. So what extra we gonna cover in this grade, right, in A level? So basically, if I talk about AS level, what we have learned in binomial theorem. So first of all, binomial mean two terms, right? So we did the expansion of two terms in AS level. So definitely in A level as well, because the name of the chapter is binomial theorem. So we will only learn the expansion of two terms, right? So that's what binomial mean. But in AS level, the power was a natural number, right? If you remember. So 1 plus
Yeah.
x to the power n, where n was a natural number. So if you expand n, I mean, if you expand this binomial expansion by using the formula like nc naught 1 to the power 0 or x to the power n or vice versa, you can take 1 to the power n as well. Similarly, nc1 1 to the power n x to the power n minus 1 up to so on ncn 1 to the power, sorry, it should be 1 to the power n and x to the power 0. So basically here you are getting the finite terms. Finite as in if you expand 1 plus x to the power 2, you will get three terms, right? If you remember, like x square plus 1 plus 2x.
Yeah.
If you expand 1 plus x cube, then you will get four terms, right? Like x cube plus uh, 1 plus 3x square plus 3x. So similarly, if you will expand 1 plus x to the power 4, you will get five terms. That means the terminating expansion you are getting, isn't it? You are
Mm.
getting terminating expansion. So that means what we have learned in grade AS. So when we had 1 plus x to the power n and where n was a natural number, so we were getting the terminating expansion. That means there were finite number of terms in expansion, right? So but
Yeah.
in A level, what extra we have to learn. So this time, instead of natural number, I mean, I'm talking about the power. Instead of natural number, n would be a rational number. Rational number mean it can be a fraction number, right? I mean, the power can be in fraction. The power can be in fraction, rational number. Okay, either the power is fraction or either a negative number. So if the power would be in fraction or a negative number, then then the number of terms in expansion will be infinite, or the expansion would be non-terminating expansion. That means there is no end. There will be no end of
Mm.
expansion, right? The
Yeah.
expansion would not have any end then. Okay. So this is all about what we're gonna learn in A level. Okay. So let us okay, before jump into the question, we will learn what formula we have to use here. Okay, we cannot use this formula. We cannot use the direct formula. Definitely we use this formula only. I mean the result that we gonna use in to expand this expansion. I mean the binomial expansion. Uh, it depends upon the result depends upon this formula only, right? And also this result is given in the MF19 booklet, so there is no need to learn any result. But uh, we will use the indirect result. I mean we will not use the direct result. The reason behind that is uh, the reason behind that is to I mean to understand the reason, can you do one thing? Can you can you find out the value of uh, 5 by 2 C0
Yeah.
or negative 5 C0
Negative 5C0. It says math error.
and 5 by 2 C0?
Math error.
So that's why we cannot use the direct formula here. So then what formula we have to use to expand the expansion? So we have one formula which is 1 plus nx plus n of n minus 1 over 2 factorial x square n of n minus 1 n minus 2 over 3 factorial x cube up to so on, right? We use this formula. Okay, from where I get this formula? So basically, this formula comes from this expansion only. I mean this result only, because if you will expand NC naught, then you will get 1. If you will expand NC1, then you will get n. If you will expand NC2, then you will get n of n minus 1 divided by 2 factorial. How will you expand that? Because as we know, maybe we have learned this formula in permutation and combination in grade AS. So it was n factorial, r factorial, n minus r factorial. Have we learned this?
Yeah.
Okay. So if you expand this formula, then you will get these results only. Right? Similarly, if you will expand NC3, you will get n of n minus 1, n minus 2 over 3 factorial. So basically, I'm getting uh, this expansion from above result only. But the thing is, I cannot use the direct formula, I mean direct result, because the reason behind that you have already understood, right?
Yeah.
Because you were getting the math error. Okay. So this was all about the introduction of this particular topic. Now I think we can directly solve one question, then you will more understand.
So we just do till x cube.
It depends, but hardly they will ask till x cube. Sometimes they can ask till x square as well, till x as well sometimes, but hardly they will ask till x cube. Let us say if they ask uh, till x to the power 4 or till x to the power 5, then what we can do, We can elaborate this expansion like n minus 1, n minus 2, n minus 3, divide by 4 factorial, x to the power 4 up to so on.
Hmm. So this is like the general formula for
Yeah, this
everything,
is
right?
exact. Yes, this is exactly the general formula for everything.
Okay.
Okay. Okay.
Yeah.
So now we can solve one question to understand it more. Okay. So I will read this question properly. So expand each of the following as a series of ascending power of x up to and including the term x cube. That means we have to expand it till x cube, right? Stating the set of values of x for which the expansion is valid. Oh, so what is this? They said stating the set of values of x for which the expansion is valid. So that means the particular expansion that we gonna expand is not valid for every values of x. So we have to do something. I mean we have to write the restriction of x for which the expansion is valid. Okay, or we have to write the radius or the interval of x, so for which the expansion is valid, so that we will learn. Okay, so let us expand the expansion first. Okay, so what is the question? The question is 1 minus 2x to the power minus 3. So 1 minus 2x to the power minus 3. Okay, so before solving the question, we have to actually check uh, f- the uh, the form of a term. So basically, I need the expansion in this form. I mean, I need the question in this form. In this form means the first term must be 1. Let us say if it is not 1, then I will make it 1. So maybe we can learn that particular part in the further questions. So in this question, basically we learn how to expand it. But
Hmm.
anyhow, we have to check is this form is same as the general formula form, right? That means is the first term is equal to 1 or not? So yes, it is equal to 1. I know the second term is not x, but it's fine. Instead of x, I can put minus 2x. I think I will solve it, then you will more understand, right? So nx n minus 1 x square divide by 2 factorial and n minus 1 n minus 2 divide by 3 factorial x cube. Okay. So instead of n, what I will put minus 3, and instead of x, I will substitute minus 2x. I hope this part is clear to you. It is minus
Are we
3,
gonna are we gonna put minus 2x or just 2?
minus
Minus 2.
2x, minus 2x.
Oh, okay.
So minus 2x square divide by 2 factorial, and it is minus 3, minus 3 minus 1, minus 3 minus 2, and minus 2x to the whole cube divide by 3 factorial, right? Because we have to write the expansion by x cube only. So it is 1 plus 6x plus minus 3 minus 4 into 4x square divide by 2 plus minus 3 minus 4 into minus 5 into minus 8x cube divide by 6. Definitely you can use the calculator to solve this question. So 2 2's the 4. Then it would be equal to 8 2's the 16. 16 5's the 80 x cube, right? And it is equal to um, 2 2's the 4. 4 2's the 8. 8 3 is the 24. So 24x square and 6x plus 1. So this is what the expansion of this term. Okay. So this is all about the expansion of binomial. So do you want me to explain you the validity, right? I mean now, or you want to note it first?
I'm gonna note it first.
Okay.
Okay.
Okay. So now we will learn the validity of this expansion. So validity means this expansion is not valid for every value of x, right? So this expansion is valid for only particular terms. So now the question is why? Why this expansion is valid for only particular terms? Why not for all value of real number, right? So okay, I'll give you the answer. So I'll give you the example first of all. So let us say if we have 1 minus 2x to the power 1 by 2. Okay. So if you ask me to expand the expansion by x cube, so I will definitely use the same formula and I will expand it by x cube, right? But if I put x is equal to 1 here, then what will I get? Minus 1 to the power 1 by 2, which is equal to square root of minus 1 and iota, right? Though we have learned about the iota, I mean we have learned the complex number, but actually here we are talking about a real number, right?
Yeah.
So that's why it will not exist. So that mean for every value of x, this expansion doesn't exist, right? Then for what value, question is then for what value of expansion, x, this expansion will exist. So to check the existence of expansion or to find the validity of expansion, so what you do always, whatever the number you will get after 1, so for example in this expansion, after 1 you are getting minus 2x, right? So what you will do, you will you will take the mode of minus 2x or absolute function of minus 2x and you will make it less than 1. You will write it less than 1. And after that what you will what you will get mode of x is less than 1 by 2 and it is equal to and x lies between minus 1 by 2 to 1. So basically, if you put any number between minus 1 by 2 to 1 by 2, between, right, not included 1 by 2 to minus 1, or not included 1 by 2 and minus 1 by 2. If you put any number between minus 1 by 2 to 1 by 2, so the expansion of this term will exist, otherwise it will not exist. Right.
Uh,
Right? So
yeah.
every time you have to put it less than 1. I mean, every time you will take
Um,
the modulus of this function and make it less than 1.
okay.
So similarly for this question, maybe you will get the same answer because if you will put modulus of minus 2x less than 1, then you will again get mod of x less than 1 by 2 and x lies between minus 1 by 2 to 1. So every time, I mean maximum time they ask the question. So if they ask this question in 5 marks, so in 4 marks they will ask you to expand the expand the expansion up to x cube or up to x square, and in B part they will ask write the validity of this expansion. So then you will always do the same procedure. Uh, write the function inside the modulus of x, right? I mean modulus, and you will make it less than 1, and whatever the value of x is, you will write.
Okay.
So do you want to try one question?
Yeah.
So it is the next type. See how to approach this question. Next type as in here we do not have journal I mean journal form, right? So what journal form is? So journal form is 1 plus x to the power n, right? So we do not have this form. That means one of the terms should be 1, right? One of the number should be out of 2, one of the terms should be 1. So but we don't have that. So before starting the question we have to make the journal form. Without general form, we can't start it, right? If we want
Mm.
to apply the same formula, so we have to make the general form, right? And if you see, uh, the same formula is given in the formula booklet, and if you see the overall expansion, so it is given for this general term only. The expansion is given for this general term only. That means how anyhow you have to make the same general term. So see how we can do that. So what's the problem here? The problem is 2, right? So now the question is, how can I take 2 common? Because it is, overall power is minus 2. So if I take 2 common, would it be 2 to the power minus 2? Because I will take 2 outside the bracket. And wouldn't be 1 plus 3x by 2 left inside the bracket?
Uh, yeah, but why are we taking the -2 again? Take the power.
Where? In the second bracket or in the first bracket? I mean, in the
The
first one.
second one.
Second one, though, it will remain same, no? The power will remain same in the second expansion, right?
So, like, why are we taking in the first one?
Because we have to take 2 outside the bracket. Because it was whole to the power minus 2, so that's why I can't write
Ah,
only
okay,
2
okay.
to the power 1 outside the bracket. So
Yeah,
maybe the problematic thing is this one. Did you understand why did I write 2 in the denominator?
yeah.
Okay. Then what I will do, I will expand it by x square, and whatever the expansion I will have, so I will multiply it by 1 by 4, right? So for example, it is 1 plus minus 2 into 3x by 2 and minus 2 minus 2 minus 1 minus 3x by 2, sorry, plus 3x by 2 to the whole square divided by 2. So it is 1 by 4, 2 and 2 will get cancelled. So it is 1 minus 3x, and it is minus 2 minus 3, 9x square divided by 8. So it is 1 by 4, 1 minus 3x plus 2 fours are 8. So it is 27x square by 4. So it is equal to 1 by 4 minus 3x by 4 plus 27x square by 16. So that's how we have to solve this question. I believe you understood.
Yeah, I understood.
Approach to this question. So this is question number um 12 of the same exercise. When 1 plus 2x, 1 plus ax to the power 2 by 3, where a is constant, is expanded in ascending power of x, the coefficient of the term in x is 0. Find the value of a. So basically we have to expand it, and whatever the coefficient of x there will be, we have to equate it with 0 to calculate the value of a. So now the target is we have to find the coefficient of x. As we have learned in AS level as well, that we have to keep this term as it is, and we have to expand the expansion of 1a plus ax to the power 2 by 3 first, right? If we apply the formula, because we have to expand it by x cube up to x cube, sorry, up to x, so it is 1 plus 2 by 3, because it is nx, no? 2 by 3 a x.
But they didn't mention till which.
They mention in ascending power of x, the coefficient of the term in x is 0. So if the coefficient of term in x is 0, and if we have to find the value of a, that means we have to expand it by x only. Okay. And see, we got 1 plus 2 by 3 ax. Now we have to multiply 1 plus 2x. So we have to multiply 1 plus 2x. So if we multiply 1 plus 2x, we get 2x. And see, we need only x terms, right? I mean the terms having x. So we get x from if I multiply 2x and 1. We get x if I multiply 2 by 3 ax by 1, right? Okay,
Um,
I believe you
yeah,
understand. Okay, now I can take x common and I'll have 2 plus 2 by 3a. Now as they said the coefficient of x is 0 if we expand it. So we can equate this by 0 and we get 2 by 3a is equal to minus 2 and a is equal to minus 3, right?
yeah.
Okay, so now in second part what we do, we have to, I mean when a has this value, find the term in x cube in the expansion, I mean in the same expansion. So 1 minus 3x to the power 2 by 3 we have to expand. So it is 1 plus nx, that means 2 by 3 into minus 3x plus n into n minus 1, that is 2 by 3 into 2 by 3 minus 1 into minus 3x to the whole square divided by 2 factorial plus n, n minus 1, n minus 2 minus 3x cube divided by 3 factorial. So it is 1 minus 2x plus 2 by 3 into minus 1 by 3 into 9x square divided by 2 plus 2 by 3 into minus 1 by 3 into minus 4, minus 6 and minus 2, that is minus 4 by 3 into 27 x cube divided by 6. So 3 will become 27. So all these 3 are cancelled by 9 and 27. So 2 and 2 will get cancelled. So it is 1 minus 2x plus x square, and it is plus 8. So we can say 2 3 is the 6. So it is plus 4 by 3, right? Plus 4 by 3 x cube. So that's how we have to expand it. But one more term was left. That was 1 plus 2x. So if we multiply it by 1 plus 2x,
Isn't it
mm-hmm,
20 over 3 x cube?
20
20 over 3 x cube.
final answer.
Yeah. Like, I mean, like, instead of 4 over 3.
Instead of 4 over 3, it is 20 over 3.
Yeah.
Wait, minus 1 by 3, minus 6. No, I think it is 4 over 3 only. How are you getting 20 over 3?
Wait, let me do it again.
Yes, please check it. Okay, by the way, in this question, we have to find the term in x cube. and simplifying the coefficients.
Oh, yes.
Okay. See, you are using the calculator and I'm doing without calculator. Still you are getting wrong. Hmm? So 1 minus 2x plus x square plus 4 by 3x cube, and it is, if I multiply by 2x, then I'll get 2x minus 4x square plus 2x cube, and I will not multiply 2x by
Wait,
4 by
they are
3x
saying
cube.
to find, what are they saying to find in the question?
Find the term in x cube.
Find the term in the
In x cube.
exam.
That means we are not supposed to find the coefficient of x cube only. We have to find the term in x cube.
Uh,
Term in x cube or terms in x cube? Term in x cube. हाँ मतलब the overall term in x cube. So it is 1 minus 2x plus 2x will get cancelled, and it is x square minus 4x square is minus 3x square, and 6 by it is 10 by 3 x cube. So this is the possible answer. That's how you have to solve this question.